Okay, in this video, we're going to do the hardwiring for the Click PLC program in Lab 900 for Industrial 2. So we start this by reading or looking at the application for Lab 900. And it says, when we power this up, we're going to get a red pilot light. So what we need to do at this point is we're going to go up here. We went and clicked on the tab Schematics. So now let's go ahead and go to the icon menu. And you see all the icons here. I need the red pilot light. And I'm going to put that right up here in the first rung. And we're going to label this PL1 for pilot light 1. I'm going to click OK. Now, you might ask yourself, how come I put it here? Well, with the Click PLC X's, let me see if I can bring this a little larger. Here we go. X's, like I've got X1, 2, 3, 4, and so on this side, those are inputs. Outputs for this particular PLC are Y1, Y2, Y3, and 4, 5, and 6, so it has at least 6 outputs. So this side over here is the things that I want to turn on when the PLC program tells them to. Over here would be where I bring a signal into the PLC to tell it to do something. So these are my inputs over here. These are my outputs over here. Okay. So we got our first output over there. And again, when I power this up, I should get that red pilot light coming on. The next line in here says that I need 2 push buttons. One is to start the operation, and the other one is to stop the operation. So we've heard of those before. We need a start and a stop push button. So I'm going to click here. I'm going to go to Components. Here are my push buttons. So I need a stop button. Now I always like to start with the stop button in my program. So we're going to put stop, and I'm going to label it push button. PB for push button. So there's my stop push button. Remember, it did say I need a start push button. So I'm going to go back to here and find a normally open one. Put that in my program. And label that start push button. Okay. We go on from there. Next group of components we need to look at says that we have a pneumatic cylinder in our operation. When that cylinder extends, it's going to hit a limit switch and turn on a green pilot light. Okay, so to make a cylinder extends, you need a solenoid. And I know from reading through this, I'm going to have at least 4 pilot lights. So I'm going to keep them all grouped together up here. And I'm going to put my solenoid here at Y5 for my output. So again, I have to get my components. And I need my solenoid. I'll put that down here on Y5. And to make it a little bit more clear to whoever might happen to need this to troubleshoot a circuit or whatever, I'm going to tell them it's an extend solenoid. So when the button is pressed, I'm going to get the extend solenoid. Now it said once it makes a limit switch, I'm going to get a green light on. Well, let's make sure we get an extend limit switch over here as our input. So again, I need to go to my components, find my limit switches, need a normally open one, and again, EX for extend, limit switch. Okay. And then I have to have a light that comes on when that happens. So in this case, I need another pilot light. And it said a green one has to turn on. So I'm going to put my green pilot light in here. And I'm going to label it pilot light 2. 5 seconds after the green pilot light energizes, there will be a third pilot light that will energize. So we need another pilot light. So we're going to go back to our pilot lights. And I know on our trainers the next one will be amber or yellow. Put that in there. And this is pilot light 3. And after that, third light comes on. 5 seconds later, we're going to get a fourth light turn on. So I need my fourth pilot light. And in this case, with our trainers, I know the fourth one is a blue pilot light. Good. There we go. That's pilot light number 4. And it says after the fourth light comes on, 5 seconds later, the system will shut down automatically. And this, of course, will cause the cylinder to return to its original retracted position. Okay, in this lab, we are using a valve that has a solenoid to operate it and a spring to return it. So in this case, all we have to do is de-energize the solenoid to get the cylinder to retract. Okay, so we've got everything we need here, but it does not mean we're done. So what we need to do at this point is we're going to get rid of all these extra lines that you see in here because they are no longer needed. So I'm just going to do something like this. Oh, let's try that again. So I could get them. Maybe it won't let me. Well, we'll just click on them individually. Okay. So what I did was I removed all the wires coming in to the inputs I'm not using. If we would have left those connected, the PLC would have saw from X4 to X8, it would have saw those inputs and it would have thought it needed to do something in the program. It really wouldn't have caused any physical damage, but what it would have done is it would have slowed down the processor. Because we're not using them, it still has to read them if they're getting an input to them. So by removing those wires that were drawn in there, those inputs will not show up or even be looked at in the PLC program. We have to do the same thing over here. So in this case, it is going to cause an issue because we have, which would be our hot lead on this side and our neutral lead on this side. So if that closed, we would have short on this end. Okay. There's some more things we need to do to make this a completed program or completed drawing. But a better choice of words. So I'm going to click on this one and I'm right clicking and I'm going to align these. So I want to make these all the same. So I clicked on the first one, hit align, and now I can click on any of these that are below it. And now when I hit return, you see it straightens them all up. Okay, so there's my pilot lights. There's my solenoid all ready to go. Over on this side, I've only got 3 inputs. I've got my stop push button, my start push button, and my extend limit switch. We're almost done. There's a few other things we need to do. First off, I'm going to click on this wire, and I'm going to go to wire number, because I need to give that, that wire from the push button, pardon me, from the push button to the PLC a number. So that wire is going to be X1. And we do that so it corresponds to the actual input address. That way anybody looking at that wire or seeing that wire would know where it fits into the PLC program. And I'm going to do that with each of the wires that we have here. Okay, and then my last one, of course, it's going to be X3. And we got our input, the wires coming from the limit switch, the push buttons, all numbered. Those wire numbers correspond to the addresses on the input card. We have to do the same with the outputs. In this case, we start with Y because it's an output, and it's Y1. As you can see as I'm filling these in, it's going to make it a lot easier for the technician who's working on this piece of equipment to troubleshoot the circuit. Okay, we got a few more things we need to number. This wire going down the side here is going to be, I have to have a number, and in this case I'm just going to make a 1. Over here, wire number is going to be a 2. See, it's a little bit tedious to get all these in here, but one of the reasons it seems to take a little bit of time is because I'm doing this remotely. So I'm actually using my computer at the school through my laptop here at home to put these numbers in place. So there's a slight delay. Okay, what I want to do now is you should always have your wire numbers inside your drawing, not to the outside. The outside numbers, the numbers on the outside here, should be rung, or in this case, line numbers. Okay. I've got a 1 over here that I'm going to pull in for this one as well. Okay. So now it looks a little bit better. You can see on the left-hand side, I now have a number 1 wire going to my stop button. Number 1 wire will go to my start button and to my extend limit switch. On the other side of those components, the stop button has an X1, the start button has an X2, and the extend limit switch has an X3. Over here on the output side, you can see I've got a 1 going to C3 and C4. Those are what are referred to as commons. And going through the output in the card, it becomes a Y1, Y2, Y3, Y4, and Y5. So if you think one comes in, goes through this contact, and then goes out to whatever it is that I'm going to energize. And then, of course, I have to have a neutral on the other side of that, so that's where number 2 fits in. So with PL1, I've got Y1 coming into it, and number 2 going to the other side of it. Y2 for PL2, and a 2 going to that on the other side. Y3 goes to PL3, and number 2 goes to the other side of it, and then Y4 goes to PL4, and the number 2 goes to the other side of that one. And then our last one, our solenoid, has a Y5 going to it to energize it, and a number 2 here to allow it to be energized, complete the circuit. So that's what your hardwiring should look like for this Lab 900 program. Okay, if you got questions, email me or contact me on WebEx, and I can hopefully answer those for you. Okay, thank you.